So this one says the deli owner has determined that his revenue Y from the selling of sandwiches each day is at most negative 0.5 x squared plus 6x, where x represents the number of sandwiches he sells. To make a profit, his revenue must be greater than his cost, which is 1.5x plus 45. Which systems of equations represents the values of y and when he makes a profit? So when we say at most, means he doesn't go any greater than. So we're going to say y. So this first one says at most. So I know that the I got to figure out which inequality this is. Okay. So at most means it doesn't go any bigger than that. So it would be less than or equal to. All right. And then for the next one, must be greater than. So this has to be greater than 1.5 plus 45. So we're going to graph this real quick. Now I'm actually going to plug in y because it needs to be less than or equal to, less than or equal to, why does it have a y? Oh, I see y. Less than or equal to negative 0.05 x squared plus 6x less than or equal to, and let's just do a standard. On my x, so I'm going to change this from because we have to sell, x represents the sandwiches. So I'm going to say 0 to, I don't know, 100 sandwich. Oops. 0 to 100 sandwiches. And the y-axis, because it's going to go from like, I don't know, 75 to 175 on the y direction. So 175. All right, there we go. That's pretty good. And so then this next one is got to be, oops. Can I undo? Nope. All right, and then the next one is going to be y is greater than or equal to 1.5x plus 45. Oh, plus sign. All right. So we're going to zoom in right here. The solution set is the shaded region where they overlap. So I've got this one and I've got this one. Let's take a snapshot of that. Well, actually, no, I don't want to take a snapshot of it. So the question says, what about 3090? Will 3090 work? Well, if I go to 30 and 90, so I'm going to go here, will 3090 work? So that one seems like a viable one. What about 6160? So then if I go to 60, how was I able to do that a second ago? $61.60 and $30.90. Wait a second. 30 is here. 90 is here. 3090 is right here. It has to be greater than. Oh, you know what? This is just greater than. This is not greater than or equal to. Oh, I see. So what they're saying is, all right, 3090 is right here. It's right on the boundary, basically. So because it's on the boundary, it's not more than. You only way you make a profit is if you're above the dotted line. And this is right on the dotted line, so you can't make a profit at 3090. But at 6160, so when I come over here to 6160, I'm definitely above the dotted line. Does that make sense? So at 61, oops, 60, oh, wait now, just a second. This is 60. I think I got that backwards. Yeah, I do. So let me take a screenshot now. Let me take a screenshot of this and then we'll talk about that. I'm looking at two screens. It's throwing me off. So this is the graph we're looking at. All right. And we're comparing 30, 90 and 60, 160. So, and we're determining if it's viable or not. So if I come over here, when this is 90, 3090 is right on the border. And so that is not viable because it won't work. It's not a solution because it's actually right on the border. And greater than is not greater than or equal to. So because it's just greater than, it's not a solution. Oh, shoot. 60, 160, if I come over, if that's 30, let me look at the original graph again. So this is 30, so right in the middle is 30. So this is 40, this is 60. 61, 60 is about right here, right? 61, 60, yeah. 61, 60, comma 160 is a solution. So, because it's not on the border. And that is it.